All right, hello, this is Mr. Wallace again. This is page 3 of our Algebra 2. This is Unit 2 semester exam review. So this is the unit semester exam review. We're going over Unit 2 function basics still. This is page 3 of our review. All right, here we just have evaluating functions. We've got two different functions. We've got g of x and h of x. It tells us which one to match. The g of x, obviously we're going to match our letters. We're going to be using this rule or this equation. Same thing with h of x. H of x, we're going to be using this rule right here. Okay. So after we evaluate, we really don't need the h of x or the g of x after we decide which one we're using. Right. So for example, letter A. Here we go. We are using g. This is a single evaluation. I don't even need h. Right. I ignore it. I'm just using g. That 5, that value in the parenthesis, that means it's my x value. So I'm going to plug that 5 into the x. So 12 times 5, and then minus 3. Order of operations, 12 times 5 is 60. 60 minus 3 is 57. All right, so what that means is when my x value is 5, my y value is 57. Excuse me. All right, letter B, I'm going to plug negative 3 into the x. So it's negative 3 squared plus 2, order of operations. I use exponents first. Negative 3 squared, negative 3 times negative 3 is positive 9. 9 plus 2 is 11. I'm sorry. Okay, this is my y value. So notice my 51 is not in my x, so I'm not plugging it into the x. This is my y value, or my output of 51, so I'm doing the reverse. I'm using g, so it's going to be 51 equals 12x minus 3. Notice the difference, right? So the other ones I plugged into the x because they're in the parenthesis. This one I'm solving for x because that x is in the parenthesis there, right? I'm solving for x. Just a two-step equation. I'm going to add 3 to both sides. That gives me 51 plus 3 is 54 equals 12x. If we divide by 12 on both sides, you can use a calculator or a fraction. X equals 4.5. It's okay if you get a decimal. All right, everyone's favorite, composition of functions. Here we go. So composition just tells us which order we're dealing with. We start from the inside out, all right, from the inside out. So I'm using my h first, and then I'm going to be using my g. So the output of my inside function of h, so the answer I get for h becomes the new input into the g function on the outside function. So if I have 2 for my x value for h, well, 2 squared is 4. 4 plus 2 is 6. Okay? So that 6 now becomes the input for my g function. All right, so I'm going to plug in 6 for 12. Oh, I'm sorry, 6 for x, and then minus 3. 6 times 12, sorry about my coughing, is 72. 72 minus 3 is 69. That's my answer for letter D. All right, next one, letter E, same thing. I'm using g first this time because it's inside out. My negative 1 is my input for g. Let's see, negative 1 times 12 is negative 12. Negative 12 minus 3 is negative 15. So that negative 15 now becomes the input into my h function. So I'm going to plug in negative 15 into the x value here. Negative 15 squared plus 2. Negative 15 squared, that's going to be positive 225. 225 plus 2 is 227. We have a little O, that's just g of h. It follows the same rules as when they're just back to back. It's the same exact thing, just represented different. 0 is my input into h. So if I plug in 0 into the x, 0 squared, well, that's 0 times 0, that's 0. 0 plus 2 is 2. That 2 becomes the input now for my g function. So I'm working inside out again. 12 times 2, which is 24. 24 minus 3, that is 21. So letter F is 21. Okay, letter G. we're doing composition again. So here we go. Oh man, what happens if we just have an x? All right, what that means is that I'm using this entire h function, so the entire h function, which is x squared plus 2, plugging it into the x value of my g. So it's going to look like this. I'm going to run out of room here, I think. Here we go. So use my entire h function, which is x squared plus 2, plug it into the x of my g function. So it's going to be 12. Instead of the x, I'm going to be putting my entire h function. So that's going to be x squared plus 2. And then I'm going to finish out my rule here, so minus 3. Okay, so instead of the x, it's going to be my entire, what my h function was. Now I use my distributive property, double rainbow, let's simplify. 12 times x squared is 12x squared. 12 plus 2 is, or I'm sorry, 12 times 2, it's times. 12 times 2 is 24. Then I have my minus 3, so my final answer, after I combine like terms, 12x squared plus 21. There we go. All right, this next one is going to be kind of long. So I'm going to break this off, hoping to keep it organized for you, okay? So same thing, I'm using the entire g function and I'm plugging it into the x of my h function. So my g function is 12x minus 3. So if I use that, plug it into the h, it's going to be 12x minus 3 squared plus 2. Okay, so this is where if you need to rewind it or pause it, that's okay. So here, there's a lot going on. This 12x minus 3 squared means it's that quantity multiplied by itself twice. So 12x minus 3 times 12x minus 3 plus 2 at the end there. And if you do like the FOIL method or the inside out or double distributive property, I'm going to write the final answer out here and circle it. You can do the math on your own to see if you get that final answer. I'm going to run out of room. So basically you would multiply the first terms, the outside terms, the inside terms, and then the last terms. Basically double distributive property, right? And then don't forget your plus 2 at the end there. So the final answer is 144x squared minus 72x plus 11. If you have a question on one of these, go ahead, we can ask one of our Algebra 2 teachers, myself, one of the other teachers, and we can show you how we're going to multiply this out. But if you do the double distributive property to the separate terms in each of the parentheses, combine all like terms, that's our final answer. Okay. All right, here we go. Number 5. We're given two functions, 3 of x plus 7 and then x minus 7 over 3. We're going to find the inverse of one of these and see if they match. And if they match, then they are inverses. So I'm going to take my f of x equals 3x plus 7. So that's just y equals, because f of x just stands for y equals 3x plus 7. And I'm literally, inverses is where the x and y's switch. Okay, so that turns into what? That turns into x equals 3y plus 7. See how my y turned into my x and my x turned into my y. After I do that, now I just solve for y, and then I'm given the inverse equation. We're going to see if it matches that. And if they do, they are inverses. So I'm going to subtract 7. These are not like terms, so it's just going to be x minus 7 equals 3y. And last step, if I divide by 3, well, I have to divide everything by 3, so I'm going to divide everything by 3 there. My y is now by itself, so that's going to be y equals x minus 7 over 3. Does that match this equation? It does. My result tells me that they are inverses. There we go. All right. Last one for page 3. Determine the domain and the range of the following graphs. Here we go. So these are endpoints right here, so that means it touches it and includes it. My domain, we're going to use interval notation, is my leftmost x value to my rightmost x value. Well, that is from 1 to 5, and since it touches both, it includes both. It's going to be bracket 1 to 5, closed bracket. My range, my bottommost y value to my topmost y value. So not where the graph ends, but my highest point. So that's going to be 0 and 6, my lowest y value to my highest. Domain, well, my x values, these with the arrows, it means it's going to go on forever to infinity, and since it's going out and out, it's going to include all real numbers, basically. So my domain, all my x values, negative infinity to positive infinity. My range, my bottommost, well, it's coming from negative infinity, right? My bottom to top, it's going to be negative infinity. Now, where's my topmost y value? Oh, it stops at the 4. And since it touches it, it's a bracket. Okay, domain, obviously no infinities here. Domain, my leftmost x value to my rightmost x value is negative 1 to 5. Leftmost x value to rightmost, leftmost to rightmost, they both touch. Oops, that's a bracket, sorry. And then my bottommost y value, not my y-intercept, but my bottommost y value, which is negative 3, touches it, so it's a bracket, goes all the way to my topmost, and that's also there, positive 3. Okay, this was page 3 of our Algebra 2 Semester 1 unit review, semester exam review. Thank you.